All right. So today, the plan is to code stacks and queues and just to code them all. And I'm going to start by coding the linked list version of them because that's relevant to what we've been doing. I'm gonna do a queue first, and then I'm gonna do a stack, and then after that, I presume we'll be out of time. If we're not, then we'll go and code a stack as an array, and then the queue is an array, and that's literally all we gotta do this week. So we got 2 days to do this. Four versions, 2 days. We'll be good. And after that, like I said, we're done. So really, make sure you all bring questions next Monday for a review day, because otherwise we'll have nothing to do on Monday. So I'll just start doing some random Python or something. So yeah, okay. So let's go ahead and do it. Unless anybody wants me to do a different version first, I'm just gonna go ahead and do a queue. And yeah, okay. So do I want to make it templated? What do we think? Should I make it templated or not templated? What would help you better? Would the templated code make it unnecessarily complicated, or would you like to see what it looks like templated? Otherwise, we just make a queue of integers or something. If there's no preference, then I'll just go with templated, I guess, because I have the templated node class already. Templated. Okay, there we go. So we shall go with that. I don't need to have a previous pointer because it's not a double linked list. So I'm gonna just go ahead and have a next pointer. I'm gonna call it next. No, I'll leave it n because that was kind of nice to not have to write a lot. So I'm just gonna get rid of this p stuff. So now we got the data here, and we got the next pointer and data. Yep. Okay. So here we got our templated node, right? This is from the last code, and now we're just gonna make the class. So I can probably do both in one file, queue and stack, because they're using the same node templated class. And then we'll do in a separate file the arrays of each one. That way it's not some huge, massive file. So template class T class Q. Is that a reserved keyword? Probably not. Okay. All right. So again, if we remember, I can. Let's see if this thing still works. Coding an iPad. Yeah, it still works. Kinda. It's kind of cut off, but yes, it works. Remember here. I forgot about our stick figures. These are the things we want, right? We want an Enqueue function and we want a Dequeue function. And that's pretty much it. So we're just going to basically add those two functions in there. So the Enqueue function does not return anything, so that one's void. But it does take a parameter, which is what we want to enqueue. The dequeue function, on the other hand, returns the item that we're dequeuing, so we want to make it valid returning. And then it does not take any parameters in. Okay? In addition to that, it would be a good idea to have a constructor and a destructor for memory allocation purposes, just in case we want, avoid memory leaks. I mean, hopefully the queue's empty at the end of this, but better safe than sorry. Okay. We don't need this rep print stuff, but I am going to leave these two functions because I'll use those. The print. It'll be nice to see what's in our current queue and to be able to destruct. So I will add one extra function here, which is just a print, so that we can see if the queue is built correctly. Okay, and we also want to make this all public just to make our life easy. Internally though, I am going to make my head pointer private, which I don't call head. I'm going to be calling front of the queue. In fact, we need one front and back, right? Let's do one front and then one back. We have front, back. We have the top and peak. We don't really need those. Peak is just to return the first thing. We could do that. We could have a peak, but let's just get the core stuff working first, and then we can go and throw more functions if we want. Okay, so we got our front and back pointer. We got our queue, print, dequeue, enqueue, print, yeah, okay, so that's pretty much all we need. So let's go ahead and add in all those functions, at least the body of the function, and then just fill it up later. So this is going to be a constructor, so we're going to say q asterisk qt colon q, right? There we go, that's a constructor. And then we got a destructor down here we can use. Am I really going to save that much work by rewriting this? Maybe, maybe not. We have a curve pointer. Instead of the head, we get the, what is the front? Yeah, the front. And then, well, curve is not equal to null, no curve is next, delete, and then set front and back to null. Okay, I think that's okay. I'm just trying to remember visually how we set our front and back pointers. So we said the best way to do it is to go ahead and use this method, right? That way we are able to easily remove things from the front. So, yep, if we do that, we're okay. See, front and back. All right, so we don't need that anymore. So that's the destructor already done. Again, it's just the same destructor we used for the linked list class, so no surprise there that we could just copy paste it. The constructor is relatively simple. In fact, I don't actually need, you can just do that one inline, because all I want to do in that constructor is just set front and back to be null. That's pretty much all there is to it. The print can stay as it is. We just want to change this from DLL to say Q, curve to say front for the head, because a head pointer is basically the front pointer. So I'm just replacing all instances of head with front. And then we can have an end, and then cur D. What is cur D? Oh, the data. And cur next and cur next. Okay. So that's all good to go. Just make that say Q. And yeah, okay. All of that is all good to go. So we have these functions done. These two functions are done, and then this one's pretty much done too once I give it a body like that. So now all we gotta worry about are actual Enqueue and Dequeue, the interesting functions, okay? So let's go ahead and just again write the head here. So void Q Enqueue TD, and then let's go ahead and write the prototype here for the Dequeue as well. So TQ Dequeue. Okay, and now we just have to write that. But for now, I'm just going to see if this code compiles. Fix any errors we might have. So it compiled, I think. Did it compile? No. It was not declaring the scope. If front instead of H. Okay, it compiled. In fact, let's try to make an object of it. Okay, we should get a warning that that there's no return statement, but that's okay. So Q1, and then if I say Q1.print, no matching function call for that. What are you complaining? Oh, I said no. They're called front and back. Node asterisk curve as front. I feel like I'm missing a semicolon somewhere and it's breaking this whole code from what I'm seeing here. Where is that at? Class Q, Q colon front null back null PTR. I'm tired. Class Q public Q. Okay, so hold on. There should be a semicolon there in the first place. And then why does it keep switching me over to the terminal when I'm compiling? It's bugged out. This function looks funky for some reason. Curve front. If front is equal to null PTR. This is what happens when you copy paste code. Public Q front. Okay, let's remove this for a second. And let's see if it complains still. No. Okay, maybe we want something like that. Nope. Nope, no. Doesn't not like the uppercase. I don't know what's wrong with it right now. I'm just throwing things at it, seeing if it fixes it. No, but you know what I'm going to do? I'm going to trust more what the compiler actually tells me on the terminal. So you're right, I should do that. That's my first mistake here, to trust this. So where's this at? This is an active. So let's just trust this. G++ main.cpp. Okay, so now, yeah, there's something weird here. What is the first error that we get? Require from here, line 55. Q int Q1. Yep. Error. No matching function call for node back null PTR. No, it's not that. Null PTR. Okay, let's do that for a second. Yeah, move this down so y'all can see it. There's wait. Maybe is there a semicolon missing here? Oh no, I was like, oh, maybe that semicolon's missing. Okay. If I remove this line, so if I don't make a Q object, does it complain? Let's start out with that. Doesn't complain with that. Okay. So it does not like when I create. Let's try to make a node. Let's see if the node is breaking itself. Let's make node T. Semicolon. If I make a node, does it complain? Alright, so something is wrong with the node. Oh well, no. That's normal because when I make a node, I always have to feed data in. So like I'll feed a 5 in. Okay. So the nodes are fine. If I make a node pointer, it should not ask for anything. Conflicting declaration. Okay, so there's something weird there. Oh, well, no, that's my lack of creativity with variable names. Okay, so the node pointer class is fine. I can make node pointers of that. But when I'm making the queue class, then it explodes. Let's comment out everything from those. Let's do everything all the way here. Okay, so all we have now is the constructor. No, we don't even have the constructor right now. Where is the constructor actually? Did I delete that? Oh, no, I had it in here. That's right. Okay. So now, I have my constructor. Actually, that should compile as is. Why is it not compiling right now? Let's find it. Oh, I see the error. I see the error. Well, at least I see a error, which I think is the reason why this is complaining to me. These should be pointers. That's why I think that's what was causing the error. Because their head and tail are pointers. Okay, let's uncomment everything now. Go back to how we had it. Yep, everything is nice now. Sad. Yep, okay, so. Yeah, so what happened was front and back, you know, these are head and tail pointers, right? They're pointers, like linked lists, you know, your head is your tail, it's just a pointer. It's not an actual node itself, it's just a pointer. So what was happening is I was trying to make objects. And when I was trying to make objects, it's like, yeah, we don't have a constructor for an object. Like we just have a constructor that, I mean, we have a constructor for an object, but it requires an actual, like, data to put in the node. So that's what it was complaining about. It's just that the way that was worded in the error message was not clear, at least to me at this time. It just did not resonate. So yeah. Anyways, it's good now. Very cool. Thank you for being and now I think that the VS Code has died. So sad. All right. Let us close that and reopen that. It's just like scuffed in general. Okay. Let's open a new instance of that. Why is it installing VS Code? Okay. Did it work? Or is it still broken? Is my compiler broken now? Okay, it's not broken, it's just glitchy. Okay. So VS Code is definitely not supporting us in this. It's great for Python though. Like, Python, like, just it never runs into problems. So, yeah. Okay. We can play that game VS Code. C-Line is nice, by the way. I will say that. I've used it before. So is JetBrains, a cool company. All right. So now that we can actually code, I'm gonna do one more test here, just to make sure that the actual VS Code is not it's not glitching out on the compiler. I just want to be able to see if I can actually see that output when I run it. Yeah, I'll see it. Okay, perfect. Yep, they do. Yeah, they make it for free. In fact, you should get the entire Git. I think it's called the in GitHub, the student package. It includes tons of things in there, including Git Kraken and other things. I think that's how you get the license for JetBrains. Okay, so Enqueue. So for Enqueue, we want to insert into the queue. So this is like a simpler version of a singly linked list, because all you gotta do is like insert at the beginning always. You never have to worry about inserting in the middle or at the end. There are two scenarios though: inserting at the beginning of an existing list and inserting at the beginning of an empty linked list, right? So the way you can check that is you can just check if front is equal to null. If it is, that means that the list does not exist already. So it's going to be the first node in that case. Oh, great. Now the tabbing is like weird. It's not, I don't know. I like it when it's 4 spaces, but all right. Very cool. So if that's the case, we're just going to create the node and throw it in. So actually, well, let's do that anyways up here. So let's just say brand new node, and we're going to call it cur, and it's going to be new node with the contents of D in it. And so if that is the only node there, then we're just going to make front equal to the back equal to the node that we're adding in, which is going to be cur. You can change it at the bottom. You can, but I don't want to because I know I have it set properly. So I'm pretty sure the next time I open this, it'll fix itself. And if I change it, it's probably going to permanently be messed up. So yeah. Okay, so that's all you gotta do in that scenario. And the other scenario is that there is something already in the list. So queue is not empty. In that case, you're just going to append it there. So start by saying the node. Oh, we called it cur. I don't want to call it cur. I want to call it temp because that's the name I've consistently been using throughout the linked list classes. So I don't want to confuse you by just changing my convention. I use cur just as a pointer. So yeah, there we go. So temp next. I want to set that to whatever the front is currently at. And then I want to move the front pointer to point to temp, which is my new beginning. And that's it. That's all you gotta do for inserting into a queue. It's very, very simple. Like even simpler than like the basic linked list. So that's nice. And we're done with this. So now we can think about dequeuing. Dequeuing is also simple, but oh wait, no. I screwed it up. You don't insert to the front of the queue, you insert to the back of the queue. So my bad there. So actually, we don't want this in there, right? Because I mean, look at the picture. So we want to insert at the back of the line. The front is what gets dequeued. So it's even easier in that scenario. So if front is equal to null, we can leave that in there because that's also the way that we can know if the queue is empty. But in this case, when we do want to insert, all we gotta do is just say back next gets temp, and then update back to get the temp. Okay, so we're actually updating the back because they enter to the back of the line, not to the front of the line. My bad. Okay. For dequeuing, now we actually remove from the front. So again, we want to check to make sure the queue is not empty, because otherwise, if it's empty, then you don't want to dequeue. The thing will break, right? And we're gonna have to fix what do we return in that case, because it's a valid returning function. So first of all, let's see how queue is empty, and then it's a templated function, so like I don't really know what to return at this point, because like you have to return something, right? Well, will it compile? It might compile if I just say return. It'll be very bad, but if I return like a number and this templated thing is like an object and it's expecting an object, bad things will happen. So I'll just do return and kind of go on with my life. So yeah, and how do we know it's empty? We can just say if front is equal to null ptr, then it's empty. Ideally, you just don't want to call the function when it's you know, empty. And how you can keep track of that is you can have a counter. So you know, we can add a count like size. Set that to 0. And then every time you enter something, you can do size plus plus. Okay, and you can even check that now. You can say if size is equal to 0, then do nothing. Okay, so you can do something like that too. All right, so anyways, in this case, if it's not empty, then we do want to return something. So all we return is basically the back. So I'm going to make a temporary pointer to hold the node that I'm going to be working with, which is currently at the back of, oh, sorry, at the front of the line. Damn. And then now I just need to move the front of the next item. So I will just say node, so front is going to now point to whatever the next item is. There's one more thing I gotta think about here, and that is that what if the front is like, this is the only node in the queue, right, that we just took out. This should be setting this to null automatically, because that means that this node temp next would actually be pointing to null. So we're okay there. But the back pointer may actually still be pointing to an invalid node. And while we don't refer to that in the insertion, it's still a good idea to not leave something with a dangling pointer. So I'm going to add a little if statement saying here, if front is now equal to null ptr, then go ahead and set also the back to be null ptr. Okay, and this is just for dangling pointer. Again, absolutely not needed, but I feel better with that line of code. Okay, because again, the way you check if something is empty is you're looking just at the front pointer. You don't touch the back pointer unless you know it's not empty, and at that point you'll know it's good to go. So yeah, yep, okay, that's it. That's all you gotta do. We've finished the queue at this point. Let's see if it works. Well, let's see if it compiles first, and we can fix the bugs first, and then we can actually see if it works. What are we missing here? New node D. Oh, yeah, we need to put a type in there. All right, so we made a queue of integers, so let's just throw in some integers in there. So we can say enqueue 10, enqueue. We should have made this just en, because like now I gotta spell enqueue correctly, but would help if I put the object name like an autocomplete. So I'm gonna do them numerically just so that I can see if the dequeuing works. Otherwise I have to keep track of what's up. Okay, and then let's go ahead and use the print function. That's the only way we can really see if the queue is there. And then let's go ahead and dequeue. And then let's print it again. Oh, it's cut off, isn't it? Why didn't you tell me that it's cut off? I should have said that like it was like slightly cut off. Oh, you know what it is because we have the Twitch, the zoomed in Twitch chat. That's what it is. So yeah, okay. All right, that's good. I'm glad. I've been very stressed lately. Okay. All right, let's just test it and see if it works. So now it's complaining about that return statement. Oh, also, we never actually added a return here for the Dequeue. So I need to say return my temp data back. Because that's what we want to return, right? When we dequeue something, we already removed it from the queue, and we have it pointing here with this temp pointer. But we actually want to return it. And also, another thing we want to do with it, actually, kind of important, is we want to deallocate it, right? We want to deallocate the data so that it's not a dangling pointer. So, okay. So for that, because what I want to do is I want to say delete temp, but this is a dangling pointer, so I'm gonna have to make a temporary variable. I can use temp, so I'm gonna call temp data. I'm gonna copy the value of temp data there, and then return from there. Because technically speaking, that's the only way that you can return it without using a dangling pointer, which is bad, right? It's unsafe. Not bad, it's unsafe. Now I'm debating if I actually even need the temp pointer here, because I can just use front here. So yeah, I don't need it. So I'm gonna optimize this. All right, temp data. So I no longer need this stuff, because what I can do here is I can just say front next. And then I can simply, no, but then I don't have a way of accessing the pointer to the allocate. Yeah, no, I don't. Okay, whatever. I'll put it back to how I had it then. So temp data. So that's as good as I had it. Unnecessary optimization. So I have a temp pointer, points to front. I update that pointer now for front. So the only reference I have to that node is temp. So I go ahead and access this to get the data back, delete the node, and then return the data. So now it's 100% safe. Okay, so let's just go in and out of the things in there. Is this actually an error? Or is it okay? So it's letting me run this code, but oh no, it's not. It's still not letting me because of the return statement. That's annoying. There's nothing I can return though. Well, we're gonna make it up. It's probably gonna not be happy about that. But for now, it'll be happy because it's an integer. But it will not be happy. But okay. So as we can see, it works. Get rid of that statement now. We have a queue. We insert 10, 20, 30, so you can see it there. And then we dequeue, so the 10 and 20 come out and the 30 is left behind. So if I go ahead and print out one more, if I dequeue one more time, I can say like cout Q1, just so you can see that it's actually returning the data. Let's do cout Q1 dequeue. You can see that will return us a 30. It's right there. It's just harder to see, but we put it on a new line. It's easier to see that there. So that is the enqueuing and dequeuing is working. The big bad thing is if I try to dequeue again with an empty queue, as will be the case here. Right now it's going to just say queue is empty and return a 0 if I cout it. And it'll kind of work as long as like the type, it's able to store the type. But if I make this queue of objects, then it's gonna crash because it's gonna be like, well, not crash, but it won't compile because it's gonna be like, I can't return to you like an actual object with the value of 0 on it. to show you what that means is if I make a queue and inside I make a queue of queues, basically queueception. I can make those queues inside of ints, but because the outer queue is made of queues, it compiled surprisingly. But let's try to call the function. Yeah, so now it yells at me because, as I said, I'm trying to return when a queue is empty. I still gotta return something because it's a valid returning function, and so it's basically saying like, yeah, I can't convert this 0 from an into like a queue object or whatever object it is. So this patch will work for you as long as the 0 is a valid conversion. You can cast the 0 to whatever type you're working with. So how do you get around that? Well, you have two choices. Choice one is you just make the code unsafe by getting rid of the front null check, and you just hope for the best that you don't ever call this function with a empty queue, because otherwise you will crash. That's option one. Option two is to put in some filler value here in your object that you pass in your constructor for what an empty queue represents. And then if you do that, then it's going to be okay. So like if I go in here and say like t empty symbol, and then just in your constructor you require the user to pass that in, like one object of t type. We'll just call it e here, and so you have to like fill that in. And so now when they actually build an object, they'll be required to enter like what the empty symbol represents. And then it has to be the type, so it has to be okay there. So then it would be okay. So like I just go ahead, instead of returning 0, I just return that empty symbol. And so here now I have to do, my empty symbol here is going to be -1. And for this one, my empty symbol is supposed to be a queue type. So that's weird. I guess I'll return like a queue object. I don't know. That's weird for that. You have to make up an object that represents emptiness. Did it work or did it not work? I don't know. I don't trust VS Code. I don't even know if that's working or not. But it's oh, I see. This one requires an empty object too, right? Put a 0 there. There we go. So you can see this one says queue is empty, and then this second one says basically. Actually, what is? I think if I try to see out it, it's going to yell at me that there is no overloaded operator for the see out. Yeah, no match for operator. But at least it compiled and ran. As long as you don't ever call that, you're good to go. So now, in the second scenario here, when it's empty, I'm returning an empty, whatever I specify as my empty object, which is like another queue itself. But that queue does not have a, like how do you print what a queue is, right? So that's why it's saying I have to overload the output operator. But yeah, that's just some sort of patch for that issue, okay? So that's good enough for that. Yeah, you don't have to, hopefully you don't run into that issue. Let's do the stack. Make sure that it still compiles. Okay. So with the stack, we are going to basically copy and paste a bunch of the stuff from the queue. Pretty much everything, and we're just going to rename some functions around, and that's it. Like, it's going to be so fast to do. It's going to be like ridiculously fast. You're going to be like, oh my gosh, that's it? That's all you got to do? And be like, yep, that's all you got to do. So I copied and pasted it. I could control F and replace things, but I'll just manually do that. Replace the words queue with stack. That takes care of that. That. We don't actually need a back pointer for the stack, so we are going to get rid of that because it makes our life easy. Less work to handle. This empty symbol thing, yeah, we'll leave that in. Why not? Oh yeah, we never looked at the size, but I'm pretty sure it worked as long as I actually added size minus minus to the Dequeue, which I didn't, but I can do that really fast. There we go. So yeah, but again, that's not part of the code. Just something that I was doing because I want to see the size for fun. But yeah, we copied and pasted it, and now we're just going to go ahead and change the Enqueue function to call it the push function, and we're going to change the Dequeue function to call it the pop. Okay, and then now all we gotta do is basically copy and paste all the functions. So all of these, print, Dequeue, Enqueue, take all of those. I'm gonna put a bunch of space here so I don't get confused. Paste them. Reword the word stack, the word queue to stack. So this is my Enqueue, so that's my push. This is stack. This is my pop. And then my print. And my destructor. That one's literally going to be identical. I mean, again, it's just a destructor, so it just does its thing. It destructs stuff. Okay, now that I finished pasting it, I can remove this extra space now. So the destructor is good to go. Print function is the same because it's just printing it. Technically speaking, you don't usually call the front of the stack the front, you call it the top. So I am going to rename it to remain like the purest of like what a stack should be like. So that's going to be a bunch of replacing. So find front and replace with top. Okay. How do you do this? I forget. Do you enter? Yeah, there we go. Okay, so it's working. So I'm replacing all the word front with the word top. Okay, until there, because this is the queue now. Okay, so like now, for example, the print statement says like cur gets top, and then it runs through that. Okay, so I'm doing that just for naming convention to be good. And so now the push function is identical. Like you do it, whatever you have set for the Enqueue is going to be your push for the Dequeue. Okay, you don't touch that. The only one you got to modify is the pop. That's the only one you got to change, because now you don't want to take out from the back from what would be the. Oh, sorry, no, actually, no, because now I want to insert at the front. Yeah, so let's, yeah. So this is, I take that back. We will modify this to how I had it. Why do I have the word front here still? Oh, I guess I didn't replace that one because it was beneath it. Let's get rid of the back tool before I forget that. So in here, if the list does not exist, top gets temp. Otherwise, this should say top now. Yeah. So now it's inserting it always at the front. So basically, if the list is empty, you just put it at the front and set the top to point to that. And if it's not empty, then you're going to basically put it at the front of it again. So it's going to basically say temp next. It's going to take what's currently at the top. Sorry, I lost track of where this was at. There we go. Temp next. We're going to just go ahead and take that and put what the previous top was and then update the top. So that's all you're doing for that one. So just update that to that. And then for the top, all you want to do is basically copy the value somewhere, update the top to be the second thing as you have it here. And then, yeah, everything should stay the same in this one actually now. So I had it flipped. This is the one you leave the same. The pop stays the same. The one you change is the push. So pop is just Dequeue, identical to Dequeue. It should be identical, like no change whatsoever. The only thing change you might want to make is remove all the references to back. So pop stays the same as Dequeue. The change is in the Enqueue, which is push, because in the Enqueue, with the queue you insert at the back of the linked list, but with the stack you insert at the front of the linked list. So you do it using this way, and that's it. That's all you do. So again, I'll share this code so you can play with it. But yeah, let's test it out and see if it works. In fact, here, quick way to test it. Oh wait, no, because I would have to reword every single thing there. So I'll just make another one. Let's make this one with cars. I like them more for this stuff. Again, the empty symbol is going to be maybe the what's a cool one? I have to look at the ASCII table. Too much effort. Let's just use a 0 for that. Okay. I know if we put a 0, that wouldn't be a good thing, but that's fine. Okay, so now if I say s1.push, and let's put an A, and then let's put a B, and then let's put a C. Let's print it out so we can see it, and then let's pop them out by actually seeing when they get popped. That sounds weird. And here, let's do just the one with the empty one, so we can see that empty value. Get rid of that. Reference to back. Okay, so now we can see we got the stack CBA. Notice that because it's a stack, it's inserting it in reverse, right? So we pushed A, B, C, so it keeps going in the beginning. So that's to be expected. And then when we pop it, we basically get the reverse of what we put in. So whenever you put stuff, I guess one usage of a stack is if you want to reverse a list, just push it all to the stack and then pop it and it'll come out in reverse, as you can see there. And as you can see, when the stack is empty, we actually, stack gets printed empty, and then we try to pop it one more time, we get that sort of 0 filler, because we know that's the symbol that it's empty, right? We need some way of knowing that it's empty. We could also print out the size value, which should increase and decrease. So you could wrap all these things in the if statement saying like if size is equal to 0, don't print, because we have that stored in here. And I believe it's still working with the stack because we have ++ somewhere here in the push, and then for the pop we have -. So yeah, if we print it out, s1.size, if we print out this value, it should be 3 at this point. And then we print that value again when it's empty, it should be 0. So you can see here it's 3, and then here it's 0. Okay? So here, I'll label it better. Why is it glitching out on me? I don't know. That's lying to me. That's good. Why? Oh, yes. It's not lying. It's actually right. So where we at? It has a line feed added to that. That's annoying. And also the ordering of this is not working out. Okay. I gotta put that before. See how statements are weird. But now it's, oh, no, see, it's all, okay. I'm just out of it today. I'm sorry. I apologize for that. I can tell you why, but I'll tell you at the end of class because I don't want anyone's sympathy. But yeah, I'm very out of it. Okay. What I'm trying to do here is I'm trying to say size and I'm trying to say S1 dot size. That's what I want to do. There we go. Size 3, when we have 3 things in the stack, when it's empty, it's got size 0. Okay? So, yeah. There we go. Okay, so that's basically your how to do your queue and your stack coding wise. So last time I spent basically the whole class explaining to you how to code them. In fact, not last time. I spent, I believe, about 2 days, right? I can't remember if it was 1 or 2 days, but I explained all the concepts. So now it's just basically putting it in code so that you can use this for your assignments, but also so you can see what it looks like in code. This is the luxury that we don't have in 302. In 302, we just do what I did last time, which is just explain to you the concept, and then you just code it as homework. And that's how the basically the entire 302 semester goes. So, yes. That is that. Do we have any questions on this? Because I know I made a lot of little issues and errors and whatnot. So I'm hoping I didn't lose anybody as I was coding this. But now's your chance to ask. Don't be afraid. Ask the questions, and I can re-explain code that I did for a function or something if it didn't make sense. Okay. All right. That's fine. So we are going to copy this code and we're going to put it as 22. And I will update this today. Yep, I will put it in the same location as the other ones. So it's on Canvas. Yeah, I haven't shown that in a while, so I'll pop it again as a refresher where that is actually located. So stand by for a second while I open up Canvas. Okay, so hello Canvas. Go into your class 202. And then from there, I believe it's under the video lecture live stream uploads. And here it is. I even put the same link twice just to make sure you all see it. So this is the one. So this is of course the YouTube channel. You can click on this and you can watch all the videos. These are from previous semesters if you want to see them. 135, summer 202, fall 202 of 2020. And this right here is what you want. This file gets updated. So even though you see the same link, internally it gets updated. So yes, I'll upload this about 5-10 minutes after class ends, you know. Usually I do it that fast, but right now I'm also doing the extra credits. But I'll try to do it fast because I want to do that before I close the VM, so I usually do that. So yes, that code will be there. But of course, you know, ask questions now if you're confused with the code, because otherwise you'll have to decipher the code. I mean, I tried to at least tab it nicely, within reason because of what VS Code did to my spacing. It made it all squished. Yeah. Okay. All right. I mean, so we backed up the code. This code is number 22 now. Let's label it really fast. Queue and stack linked list implementation. I know you can't see this. All I'm doing is just literally labeling this. 1122. Okay. That way you all can actually like find this file. So, all right. So now we're going to literally delete everything out of this file except for the include. Because the array version of the stack and queue don't require any of the nodes or pointers or things like that. So might as well just have a clean slate. So first of all, let's see if VS Code compiles. Okay, compiled. Very cool. All right, and I'm going to do the stack because the queue, we want to make a circular queue, and that actually takes time to do. It's actually harder probably than the linked list. So we won't have time for that one today because we have 15 minutes. In fact, we might not finish the stack one either for the array, but that's okay. We'll finish it next time. Like I said, that's all we have this week to do is just code these 4 things. And we got 2 of them done today, so pretty confident we'll finish. In fact, bring some questions about the final if you, well, questions about topics, because I don't know. The final is not completed yet, so I can't tell you what's in it. But if you have questions about topics, you can bring them in on next class, because we'll probably already start reviewing next time, because we'll finish these early. If not, then definitely bring questions on Monday. Otherwise, I don't know. Like I said, I don't know what you want me to review, so I'll just start teaching you Python instead or something. So yeah, okay. Template it, since I think you all wanted templated examples. And like I said, we're going to do the stack because that one is the easier one to do. Nope, easier and faster too. So for that one, we want to have an array. And I guess this makes it harder, but it makes it nicer, is we're going to make it dynamic so that we can resize it if we run out of space. Because again, this is an array, so we gotta worry about size. So our constructor is going to take 1 parameter. Actually, no, we won't take any parameters. Well, if we don't take parameters, we're gonna run into the same issue with like the stack is empty. What do we do? In this case, it's not as terrible because we'll just get weird data out of bounds from the array. So yeah, we'll go with that mindset. That no one's ever gonna call it. Okay. Well, we're gonna make this public. And in terms of private variables, what we want to have is just the actual array itself where the stack is stored. So I'm just going to call that R for array. So it's going to be of the type of whatever the template is. But it's going to be dynamic. So I'm going to make a pointer of that actually. So T pointer array. And what I want to do when I first create the stack is I'm going to initialize it. So I'm going to say array gets T and then give it some size. So because I want to see this, I mean, normally I would pick a somewhat bigger value, but because I actually want to see this stack grow and shrink and copy things over to it, I'm going to make it of size 3, like initially. And that way we can see that, like I said, like when 4 things get in there, we'll see the resize function actually copy things over and make it bigger. So that is, that's actually a good reason for us to keep it small. Other than that, we also want to initialize, we want to have a size like before. So I'll make that one public because I do want to access it so I don't call this when it's empty. I want to initialize it to 0, so I'll just do that there. I could also do it here. So either or. Depends on how pedantic you are with old school versus new school stuff. What else? And why is this underlined already? Probably needs this. Do I need anything else for this, really? Just the size. We have push and pop. Yeah, I think I'm gonna go with something basic like this for now. And destructor. Let's make a destructor really fast. For the destructor, what I want to do, and we kind of want to copy constructor too here, by the way. That would be useful. Maybe we'll do that if we have time and nothing else to do. But for now, for the destructor, I just want to make sure that I call delete. Right? I think that's the syntax. I literally have not tried to delete this in months. An array, but I believe that syntax is good. Bothers me this is underlined. Why? Oh, because this parenthesis shouldn't be there. You don't need that? Okay. That's right, you don't need that. Trying to see if there's anything else that we need here, but I think that's it. Yeah, okay. Now for functions, we just need a push and pop. So push is going to take the value that we're pushing in. It's going to be void, just like before. And pop is value returning. We'll do those outside though. This class name is stack, so we need to put that stuff in there for both. Okay, I want to run it again just to make sure it's still good. Okay, it's still good. Let's go ahead and implement this. So for pushing, it's very nice. So here, let's quick refresher on what we should be doing for these. So where is it? So it's just queue, stack. So all we really gotta do is keep track of our top, which is basically the size. We can call it size, we can call it top, doesn't matter. And then that's the next spot that we gotta insert to. Or, well, it depends. We can keep it pointing to the next spot to insert to, or to the current top of the stack. So we are gonna do, I think actually current top of the stack. Oh no. We'll make a point to the next available spot. So we call it size, but you could also call it top, okay? Either one will work. So when you push, the first thing you want to do is you want to check if you have space available. So, that's actually one thing we should keep track of, and then we can use that as a better name. So maybe I am going to rename this to top, because guess what? We need to keep track of how big this array is, right? So, and that actually sounds like a better name for size, because or capacity. I might use capacity, but I'll still keep that at top, because that might be misleading in this scenario. And that's gonna make a private variable, because I don't want people to mess with that directly. So my capacity is going to initially be set to 3, because that's what I'm allocating. But then that's how I know when to resize. Okay, and I guess I should add here my resize function as well. That's also going to be an internal function, because I don't want anyone to call it, but whenever it's needed. So it's going to be internal. Okay, so here, let's just copy over this, and this is going to be for when the stack gets full, because again, that's something you actually have to consider. So you don't need to worry about that with the linked list, but you have to worry about that here. So there we go. We have a resize function now. Okay. So when you're pushing, the first thing you want to do is you got to make sure if you have space. So you can say if the top, if technically speaking, this would be okay to put. If top is equal to capacity, then that means that you got to resize, because that means that like index. So let's say the top is currently pointing to 2, which is the last spot, right? Because 0, 1, 2, and it's size of 3. capacity is 3, right? So if 2, oh wait, no, because in that case, if we're counting at 0, you actually want it to be -1, right? Because otherwise, yeah, so maybe the first thing that you would want to do is say top plus plus. Oh, wait, no, I take it all back that I said. Because we have to decide if we want top to point again to the last element of the list or to the next one. I'm going to make it point to the next available empty spot. So the word top, when you return 1, it's because there's only one item and the next one would go in index 1. So with that logic, with that in mind, if the capacity of something is 3, then we still have space if top is currently pointing to 2, because that means there's only spots in 0 and 1. So if top is currently 3, that's when we're out of capacity. So yeah, all that sort of brainstorming to say that, yeah, what we had was okay. So I think this is okay like that. So if top is equal to capacity, that's when we got to resize, because index 3 of an array of size 3 does not exist, right? However, to be like super duper safe, what I was going to say is I'm going to make that greater than or equal to, just in case weird stuff happens that messes with the top. Okay, so all you got to do there is just resize. And when you resize, then you can assume that it will return back to this function with a resized array, and now you're ready to insert, okay? So we'll deal with that later. Definitely not today, next class, because we have 4 minutes left. So let's just go ahead and finish the push. So assuming that we do have space, all we guys basically got to do is within our array, at the spot of top, we want to insert that point like that. And then once we finish that, we want to increase top to point to the next available spot, which may be out of bounds, but we don't need to worry about that until the next time the function runs. You can combine these two lines of code into one, and I like doing that, but I'm not going to do it here because I don't want to confuse you. But you could just say something like top plus plus, and that actually does the exact same thing, because first it's going to take the old spot of top and put D there and then increase it. So these two lines is the same as this, but again, I'm going to use the old version because I don't, I want to be the first time you're seeing this code, so I don't want to take any shortcuts that make the code harder to read. Okay, so I'll write same as above, but one line. That's basically how you push into the stack. How you pop out is just basically, well, first of all, again, you would want to check if you actually are able to, if the thing is not empty. But for now, we're just going to assume that it is completely safe, because otherwise we got to do that empty thing that we did before, because otherwise the return statement, it'll complain. None of this would be a problem in Python, probably. So, yeah. But yeah, so because of all of that, all I really got to do is just basically write a return statement, and then in there, go ahead and say R, and then return top minus 1. Why top minus? In fact, actually not top minus 1. Minus top. Because what I want is, or actually, no. Yes, like that. Because top is pointing to the next available spot. So I want to decrease top by 1 to point to the last spot that was actually full. Return that value, and then top is pointing to that spot. Now that spot has data in it, sure. But, and here's the cool thing. You can just think of it as being empty, because that data is old data that you don't care about anymore. It's garbage. So that's why you don't even need to initialize the array. Okay? So single line of code will take care of it. Again, if this makes you feel uncomfortable, you could split this into 2 lines by saying top minus minus here, and then go ahead and just do R top. So that would work as well. Okay? So either or. Just don't do top minus minus here, because then it'll break. Whereas here, it's okay to do there. And that's it. That's the entire stack. We can experiment with it more next time. I'm just gonna just play with it a little bit, because again, we haven't coded resize. So let's just push 2 things and push them out afterwards, and then call it a day. Pop them out, not push them out. Let's do cars again. So s1.push a, b and c, and then cout s1.pop. Oh, and you know what I'll do next time too is remind me I'll do a print function so we can see the contents of the stack. It'll be nicer that way. So you can see that they get printed backwards. Then you push them in because it's a stack. Okay? So, yep, that is all there's to it. All right. So, let's see if we have any questions. There's a question on the point. Yes, you need to send me a DM with your name, your section number, and your Discord name. So, not your Discord name. Sorry, your Twitch name, so that I know it's you. Now, I know in your case you have the same Discord name. So, still, just to be safe, because I have to look at like 20 different people, and it's hard to keep track of who's who. Just send me your real name, like real name, the one that's on Canvas, and then, well, some people don't have the, like, they have like weird, like the name is different in Canvas than in real life because OIT is weird and they screw up the names or something like that. But send me the name that shows up on your Canvas, whether or not it's the real name. Because like my name is missing like my middle name on Canvas. So show me your Canvas name, show me your Twitch name, and show me and tell me your class name. I don't care if you're 1004 or 1001. I just want CS 202 or 302 because I have those, and that way I just like process you faster. Makes it easier. So those three things. Anyways, as you can see, the code worked. Next time we'll do the resize and also a print function, just so you can see it. So we'll pick up from there. And like I said, we have the whole class to finish this and just do one more. Circular array will take some extra time, but we'll get it done. It's not bad. So that's it. That is all to it. So yeah, I can push if you would like me to. I can push this version of the stack as is, or hold off on that and push it on Wednesday, like this code that I just wrote right now. That way you don't get like half done code. But I will push the linked list version. Now I'm saying push because we were talking about stacks, but upload. So yeah, this one I won't push. I don't want to confuse you. So this is like half done. I mean, it works, but it's missing the resize. So yeah, I won't put this one up. If you really want to play with it before then, you can always just kind of look at the video and get it from there. It's pretty straightforward. There's only 50 lines of code, and of those, most of it's spacing. So, yep. Like I said, I apologize that I'm not in my game today, but some bad stuff happened. So, all right, I'm gonna stop the video. No, that's not what I said. I said real name, Twitch name, and class. In your case, they're the same, but for everybody else, they don't get confused. They want Twitch name because you're reading the points on Twitch, so I need to be able to see that in case they have different nicknames. So yes. All right. Okay, I will stop the stream. So, thank you all for watching. I'll see you next time. Bye.